Today, we're going to talk about glucose. Most people think that they know everything about glucose, but in reality, most people don't know where glucose came from and what it consists of. Glucose is a major component of sucrose. It's the substance we mean when we refer to sugar. Sugar has names specific to its source, such as cane sugar, beet sugar, and corn sugar. It also comes in a number of variations: brown sugar, white sugar, and berry sugar. The glucose molecule present in all of these kinds of sugar is fairly small. It has just 6 carbons, 6 oxygens, and 12 hydrogens. Although the same number of atoms as in a molecule responsible for the taste of nutmeg and gloves, but just as in those specific molecules, it has a spatial arrangement of the atoms of the glucose molecules that result in a sweet taste. Sugar cane can be extracted from many plants. In tropical regions, it is usually obtained from a sugar cane. Between 1900 and 1964, world sugar production increased by 700%. Without the demand for sugar, our world today would probably be a lot different, for it was sugar that fueled the slave trade, bringing millions of black Africans to a new world. And it was profit that the sugar trade that by the beginning of the 18th century helped spur economic growth in Europe. Some historians calculate that upward of 50 million Africans were shipped to the Americas over the 3.5 centuries of the slave trade. Glucose is the most common of the simple sugars, which are sometimes called monosaccharides, from the Latin word saccharum for sugar. The mono prefix refers to one unit as opposed to the 2-unit disaccharides, or the many-unit polysaccharides. The structure of glucose can be drawn as a straight chain or as a slight adaptation of this chain, where each intersection of vertical and horizontal lines represent a carbon atom. A set of conventions that need not concern us give numbers to the carbon atoms, which is referred above. This is known as a Fischer projection formula, after Emil Fischer, a German chemist who is in 1891 determined the actual structure of glucose and a number of other related sugars. Though the scientists, tools, and techniques available to Fischer at the time were very limited, his results still stand today as one of the most elegant examples of chemical logic. He was awarded the 1902 Nobel Prize in Chemistry for his work on sugar. Although we can still
Wait. Oh, I thought I was gonna rip that. Get out.
Although we can still draw sugars such as glucose in this straight chain form, we now know that they normally exist in a different form, cyclic structure, which is ring. The drawing of these cyclic structures are known as Haworth formulas, after Norman Haworth, the British chemist whose 1937 Nobel Prize recognized his work on vitamin C and on structures of carbohydrates. The 6-membered ring Worth formula, shown below, indicates by number how each carbon atom corresponds to the carbon atom shown in the previous Fischer projection formula. It is because humans love sugar so much that even after slavery was abolished, the desire for sugar still affected human movement around the globe. At the end of the 19th century, large numbers of indentured laborers from India still went to the Caribbean islands to field the sugar cane. Sugar continues to shape human society. We have sugar in much of what we drink and much of what we eat. Our children prefer sugary treats like candy. In our everyday lives, we continue to be shaped by sugar.